Observing Kubernetes clusters. In this series, we'll explore essential techniques for monitoring clusters, viewing work requests, viewing OKE service logs and Kubernetes API server audit logs. We'll also look at viewing application logs on managed and self-managed nodes. And lastly, we'll cover container engine for Kubernetes metrics. Now let's begin our first topic, that is monitoring clusters. Once you've created a cluster, keeping an eye on its overall health and performance is crucial. On the cluster list page, you can find a summary status for each individual cluster and its control plane nodes. The status column provides insights into the cluster's health. Let's break down the statuses. When a cluster status indicates creating, it means the cluster is being created and applications are being deployed. For a cluster in active state, indicates the cluster is running normally with control plane nodes functioning as expected. A failed state indicates an unrecoverable error has occurred and the cluster is not running. Deleting indicates cluster is in the process of being deleted and releasing resources. A deleted state indicates cluster has been successfully deleted and resources have been released. The cluster status reflects updating when the Kubernetes version on the control plane nodes is being upgraded. Remember, the cluster summary status may not directly reflect the status of individual node pools and nodes within the cluster. I'll now transition to OCI console and show you where you can check your cluster health statuses. I've already logged into my OCI console. I'll open the Kubernetes clusters service page. On the cluster list page, you can check the status of your clusters by viewing the status column. For now, as you can observe, all the clusters in my tenancy are in the active state. I'll jump back to the slide deck and continue with our lesson. Now let's shift our focus to the Node Pool tab, a vital area for understanding the status of individual node pools within your cluster. On this tab, you'll find a comprehensive summary of the status of each node pool in your cluster. Similar to cluster, even node pools come with various statuses, each indicating a specific state in the lifecycle of your cluster. Let's break it down. When the node pool status says creating, it indicates the node pool is in the process of being created as part of the cluster creation. Active state indicates a healthy node pool where worker nodes are running smoothly. Deleted indicates the node pool has been successfully deleted, releasing unnecessary resources. And when the node pool status says needs attention, this status signals that at least one node in the node pool requires investigation. For example, attempting to terminate a node in the pool may fail if the node cannot be drained and codoned within the eviction grace period. It is essential to understand these intricacies for effective cluster management. I'll navigate to the OCI console and show you the location where you can check your node pool status. I'll select one of the clusters from the list. To view the node pool status, you can scroll down and click on Node Pools under the Resources section. And you can check your node pool status from the node pool status column. Moving forward, let's explore the Nodes tab, a crucial section for gaining insights into the status of each worker node within your node pool. To get a closer look, you must click on the Nodes tab, and this action will display summary status of each individual worker node. And as in the previous cases, even the worker nodes exhibit different statuses based on their current state. Let's break down these statuses. Creating indicates that the node is currently being created with the compute instance in the process of being generated. Active indicates a healthy state where the node is running normally, performing its assigned tasks. Updating is where the node is in the process of being updated, often initiated by operations from container engine for Kubernetes. Deleting means the node is undergoing deletion, releasing resources as the application is no longer required. Deleted indicates the node has been successfully deleted, freeing up all the resources. And inactive indicates that while the node still exists, its it's not currently running. This can be due to the compute resource being in a status of stopped, stopping, or down for maintenance. Let's navigate to OCI console and check out the location where we get to see the worker node statuses. To check out the worker node statuses, you must click on the node pool name. Scroll down on this page, and under the nodes section you get to see a list of worker nodes present in your node pool, and the node state column indicates the statuses of your worker nodes. In conclusion, we've explored crucial aspects of Kubernetes cluster monitoring, understanding cluster, node pool, and worker nodes statuses. Stay tuned for more insights in our upcoming lessons. Thank you for watching. Hello and welcome to our next lesson in this multi-part series on observing Kubernetes cluster. In this lesson, we'll explore work requests in Container Engine for Kubernetes and understand how they play a key role in handling tasks that happen in the background. When you perform operations in OKE, many service requests like creating a node pool are asynchronous and tracked by work request. These work requests give you visibility into the progress of the operation, offering automation capabilities. Each work request has a unique OSID for programmatic interaction, and it includes timestamps for error diagnosis. When dealing specifically with node pool work requests, it's crucial to note that these are handled one at a time, and concurrent requests may fail. Resources managed by OKE can only support one work request at a time. As some operations depend on the completion of others, monitoring each operation's work request is essential. A successful create node pool work request is marked as succeeded when the workflow successfully creates a node and the node is registered with an active status. Now let's take a closer look at the statuses associated with work request on the cluster details page. On the cluster details page, you will find a work request link under the resources section. Clicking on this link allows us to view the ongoing operations related to the cluster. Understanding the different states of a work request is crucial for effective management. Here's a breakdown of the work request statuses. Accepted indicates that the request is currently in the work request queue awaiting processing. When a work request is in progress, it means there is a record for the specified request, but no associated work completed record exists yet. Succeeded signifies that a work request record exists and there is an associated work completed record with a successful state. In case of a failed status, a work request record exists, but the associated work completed record indicates a failure. Cancelling suggests that the work request is currently in the process of being cancelled, and cancelled denotes that the work request has been successfully cancelled. Understanding these statuses provides us with the insights into the progress and outcomes of our cluster operations. It allows us to monitor and respond to any issues that may arise. I'll now navigate to the OCI console and show you the location where we can view the work request. I'm already logged into my OCI console and I'm currently in the Kubernetes clusters service page. I'll click on one of the clusters. On the cluster details page, you must scroll down and under the resources section, we have the work request field. Click on the work request. And this is where you find all the operations related to your cluster listed. At present, there is only one operation that is listed, that is node pool update, and the status of which indicates that it is succeeded. At present, there is just one operation that is being listed, that is the node pool update operation, and the status of which says it was successfully executed. Also note that sufficient IAM policies must be in place to allow you to inspect work requests within the tenancy. For example, you can create a policy for your support team to inspect work requests in the tenancy, or you can limit the access to a compartment as well. In wrapping up this lesson, We've navigated the intricacies of work request statuses, empowering us to effectively monitor and manage ongoing operations within our Kubernetes cluster. Stay tuned for more insights in this series. Thank you for watching. Hello and welcome to this lesson on viewing OKE service logs. I am Mahendra Mehra, your senior OCI instructor at Oracle University. Let's get started. After creating your OKE cluster, Oracle Cloud Infrastructure Logging becomes an integral tool for log management and analysis. This platform allows you to examine and search the logs of Kubernetes processes running on the cluster's control plane. These logs, referred to as service logs, offer insights into processes like Kube Scheduler, Kube Controller Manager, Cloud Controller Manager, and Kube API Server. Each process log, whether it's the Kube Scheduler making decisions or the Cloud Controller Manager provisioning load balancers, is available for scrutiny. These logs, configured at the default Kubernetes log level verbosity, provide steady state information and essential messages signaling significant changes in the system. Now let's discuss why these service logs are crucial. They become invaluable when troubleshooting issues such as cluster control plane, virtual machine shutdowns, network partitioning problems, Kubernetes software crashes, data loss, or operator errors. Enabling and configuring service logs is the gateway to subsequently viewing and leveraging them for effective cluster management. I will switch to the OCI console and let's see in practice how to create a new service log object to enable viewing and searching logs of Kubernetes processes running on a cluster's control plane. I'm already logged into my OCI console. Firstly, I'll go to the navigations menu and go to the observability and management section. Under logging, I'll click on logs. I'll make sure the compartment that I'm working in is CTD OKE. This is where I have the required permissions to work in. Now to enable service log, I'll click on enable service log button. In the enable resource log window, I'll select the resource compartment, which is CTD OKE. Under the service field, I'll select container engine for Kubernetes from the drop-down. And within the resource field, I'll select the Kubernetes cluster for which I wish to enable the service logs. I'll select OKE public demo 2. I'll scroll down. Under the configure log window, we can choose the log category. We can choose from Kube API Server, Cloud Controller Manager, Kube Controller Manager, and Kube Scheduler. We can also go for all log sources. In this case, I'll select all log sources. Let's give this service log a suitable name. Under the show advanced options, we can choose the log location. I'll select the default compartment, which is CTD OKE, and under the log group, we can go for default group or we can create a new group on the fly. I'll click on create a new group, give it a name, give it a suitable description. I'll leave the tag namespace as blank and click on create. And it has automatically selected the new group which we created, that is OKE service log group. Under the log retention field, we can define the length of time in months to retain the service log. The default selection is 1 month. We can select up to 6 months. I'll leave the default selection. We can also add a free form tags or define tags. For now, I'll leave them as blank and click on enable log. A new service log with the name OKE service log is getting created. This will take some time. We can also verify the log details from the log information tab. The log type is service log. The service is container engine for Kubernetes. The resource we have selected is OKE public demo 2 and the log category is all log sources. Alright, our OKE service logs is now active. Now this will take some time before we get to see the logs coming in from our Kubernetes control plane nodes. Well, after some time we can see some log entries available here, and you can filter your log entries by age or you can filter them by time. Optionally, we can click on the actions menu and explore our log with log search. This opens up the central logging search page where you can apply filters and explore and visualize the log data in different ways. You can enter search filters in the text field over here, and you can click on the Visualize tab to visualize your information or log data in different ways. With this, we come to the end of this lesson where we covered the container engine for Kubernetes service logs. I hope you found this lesson useful. See you in the next one. Thank you for watching. Hello and welcome to this lesson on viewing Kubernetes API server audit logs. Let's get started. Let's delve into the realm of viewing Kubernetes API server audit logs. This crucial process allows us to analyze cluster activities for compliance, security, and troubleshooting. Both Container Engine for Kubernetes and the Kubernetes API server serves as audit sources. OKE emits audit events whenever you perform actions on a cluster such as create and delete, while the API server emits audit events whenever you use tools like kubectl to make administrative changes to a cluster such as creating a service. To retrieve these logs, we leverage the powerful OCI Cloud Infrastructure Audit Service. This service enables us to view all operations performed by Container Engine for Kubernetes and the Kubernetes API server. To view and analyze operations by Container Engine for Kubernetes, you must use the cluster API string in the keywords field of the audit service. To explore and comprehend operations by the Kubernetes API server, you must use the OKE API server admin access keyword within the audit service keywords field. I will switch to the OCI console and we will see how to view operations performed by OKE and the Kubernetes API server as log events within the Oracle Cloud Infrastructure Audit Service. I'm already logged into my OCI console. This is my OCI dashboard. I'll start by clicking on the navigations menu, go to Identity and Security, and then click on the Audit Service. I will make sure that I'm in the right compartment where I have the permissions to work in, which is CTD OKE in my case. We can expand the custom search based on the dates. I'll go ahead and expand the search from 16th Jan to 30th Jan. Remember from the lesson, if you want to view operations performed by the Kubernetes API server, we must enter OKE API server admin access within the keyword field. And we can narrow down our search based on the request actions type. We can select from these request action types where we have the option to choose get. Get method is used to retrieve information from the Kubernetes API server. Post is used for creation of resources. Put is used for update or creation of resources. Patch is used for partial updates to existing resources. And delete is used for removal of existing resources. For this demo, I'll narrow down to patch action types and click on search. If you recollect from our previous demonstrations where we had updated the node pool properties and patched our existing node pools, the audit events here basically represents our actions we performed as part of the node pool update demonstrations. We can click and expand the audit log entry and this displays the log data in a JSON field view. To conclude, exploring Kubernetes API Server audit logs offers valuable insights for understanding cluster activities. Whether for compliance, security analysis, or troubleshooting, these logs pinpoint the who, what, and when, providing essential context. I hope you found this lesson useful. See you in the next one. Thank you for watching. Hello and welcome to this lesson on viewing application logs on OKE worker nodes. In this lesson, we'll navigate the process of accessing and exploring application logs on OCI Container Engine for Kubernetes. Let's get started. We'll start with viewing application logs on managed nodes and self-managed nodes, and later cover how to view application logs on virtual nodes. Kubernetes application pod logs are a treasure trove of critical event, state, and diagnostic information for containerized and serverless applications. However, managing log data from a bustling Kubernetes cluster can be challenging. Enter the OCI logging service, designed to effortlessly ingest and consolidate log data from applications running in the Oracle Container Engine for Kubernetes service. OCI virtual machines come equipped with a lightweight agent, simplifying the collection of log information from host processes. Now let's delve into the crucial prerequisite steps that set the foundation for unlocking comprehensive application log insights on both managed and self-managed nodes. Our first step is to ensure monitoring is enabled for the compute instances hosting managed and self-managed nodes. This allows us to capture and track critical metrics and events. Next, if not already present, install the Oracle Cloud Agent software on these compute instances, basically our worker nodes. This agent serves as a powerful tool enabling customization of log collection and parsing based on your specific needs. The agent is installed by default on managed node compute instances. I'll transition to OCI console and we will see these in action. I'm already logged into my OCI console. I'll go to the Kubernetes clusters service. For this demo, I'll be using the OKE public demo-2 Kubernetes cluster. I'll scroll down to the node pools section and click on the worker nodes. You notice the node type is managed. Basically, this is a managed node pool, and these are the 5 managed nodes running within our managed node pool. And like I mentioned, we must ensure that the monitoring is enabled for the compute instances hosting the managed and self-managed nodes. In this case, I'll open up one of the worker nodes. This opens up the instance details page for our compute instance running the worker node. I'll go to the Oracle Cloud Agent tab. Within the Oracle Cloud Agent tab, we must ensure that the custom logs monitoring plugin is enabled. For all the compute instances created as part of the managed node pools, this plugin is enabled by default. And for the self-managed nodes, we must ensure that the custom logs monitoring plugin is enabled. I'll go back to the instance information tab. And to ensure that the Oracle Cloud Agent software is installed on this compute instance, I'll copy the public IP address of the worker node. I'll spin the Cloud Shell machine. My Cloud Shell machine is up. I'll maximize the window. Clear the screen. I'll SSH into the worker node first and run the systemctl status command to check the Oracle Cloud Agent software installation on the worker node. I will use SSH space OPC at the IP address that I had copied of the worker node and hit enter. I'll say yes here on the prompt. hit enter. And as you can notice, the prompt has changed and I've SSH'd into my worker node. Here I'll run the command systemctl status unified monitoring agent and hit enter. And from the output, it's clear that the unified monitoring agent service is up and running on the worker node machine. I'll exit out of the worker node. Now let's go back to the slide deck and continue with the prerequisite steps. The next step is to create a dynamic group with a rule that includes the target host, which are our worker node compute instances. This dynamic group ensures that the right set of instances are identified for log processing. For the dynamic group, we will use the instance.compartment_id and set the value to the OSID of our ctd_oke compartment where our worker nodes are running. Once a dynamic group is created, we must establish a policy tailored for our dynamic group. This policy grants the necessary permission, allowing the identified host to push their logs seamlessly to the OCI logging service. And the policy is to allow dynamic groups specify your dynamic group name to use log content in tenancy. You can also replace tenancy with your compartment name. I'll switch back to the OCI console, and in the interest of time, I've already created the dynamic group and dynamic group policy. Let me show it to you. For the dynamic groups, I'll click on the navigation menu and go to the identity and security service. Click on domains. Go to the root compartment here and select the default domain. Click on the dynamic groups resource. And here is the dynamic group, which includes all the hosts running in the ctd_oke compartment. As you can notice, it is for all instances running in the compartment with the compartment OSID. This is the OSID of my ctd_oke compartment. And I've created a dynamic group rule for this dynamic group to use the log content in the tenancy, for which I'll go back to the identity and security service. Click on policies, and in the root compartment I have mentioned a policy for my dynamic group. It says allow dynamic group the group name to use log content in tenancy. By completing these prerequisite steps, we lay a robust foundation for our log exploration journey. I hope you found this lesson useful. See you in the next one. Thank you for watching. Welcome back. Let's continue from where we left off in the previous lesson. Now let's go back to the OCI console. Now we'll define a new custom log object and an associated agent configuration to enable us to view and search the logs of applications running on compute instances hosted by managed nodes and self-managed nodes within our container engine for Kubernetes. I'll go to the navigations menu and click on observability and management. Under logging, I'll click on logs. Here I'll click on create custom log button. Provide a suitable name for my custom log. I'll make sure that I'm in the right compartment, ctd_oke. And for the log group, I'll click on create new group. Give it a name. Also provide a suitable description. Leave the namespace as blank and click on create. Under show advanced options, we have the option to choose log retention value. By default, it is 30 days and we can set up to 180 days. I'll leave the tags field blank and click on create custom log. A new custom log is created and the create agent configuration page is displayed now. On the create agent configuration page, we must select the create new configuration and specify the configuration name. I'll give it a description. Make sure the compartment is the right compartment where you have the permission to work in. Now under the host groups, I'll select the dynamic group that we had created, which includes managed nodes in the clusters managed node pool as target host. And remember, this dynamic group also has the permission to access the compartment where we have specified the agent configuration, and also allows the target host to push logs to the OCI logging service. Now within the agent configuration panel, we'll specify the configure log inputs. For the input type, I'll select the log path, provide it a name, let's say nginx logs, and provide the file path for our logs. For the file paths, we need to provide the path where our logs are created within the worker nodes. The location is /var/log/containers/*log. This represents all the log created within the Kubernetes cluster worker node. I'll go ahead and hit enter. Optionally, if you want to use Kubernetes namespace as a standard and set the log path to the default namespace, we must use the following path, that is /var/log pods/default_***/***.log. For now, I'll stick to the var log containers path and go ahead. Under the select log destination panel, the options are pre-populated with custom log details, which we had specified earlier. I'll go ahead and click on create agent config. We have the entry for our OKE custom log. Now to view the log, I'll click on the log name. At present, we don't see any container logs available. I'll switch to the next tab, minimize the Cloud Shell terminal, go to the Kubernetes service. This is the cluster which I am using for the demonstration. I'll click on the cluster. Make sure that I have the access to this cluster. I'll copy the command and maximize my Cloud Shell terminal. Clear the screen here. Run the command to set up the cluster access. And go ahead and run the kubectl get nodes command. It has returned a list of 5 nodes running as part of our managed node pool. For this demonstration, I'm already running an nginx deployment on this cluster, which is exposed using a load balancer service. I will run the kubectl get all command. If you notice, we have an nginx deployment with 1 pod running on this cluster, and a service has been configured of type load balancer to expose this deployment. I'll copy the external IP, go to a new tab and paste the IP address. It opens up the default nginx web page for us. Now I'll go ahead and try to access something on this server which does not exist. Let's say test.html and hit enter. It says 404 not found. Well, this event must have been logged in the nginx error logs. Let's see if the OCI logging service was able to trace it and display it to us. I'll go back to the first tab. It takes some time for the logs to appear in the explore logs section. In the meanwhile, I'll SSH into the worker node where our nginx pod is running, and I'll show you the location where the log files are created. Let me clear the screen here and I'll run the kubectl get pods -o white command. This gives me the detail of the node which is running our nginx pod. The node running our nginx pod is 10.0.10.35. I need to find its public IP address. I'll minimize the Cloud Shell terminal here and go to the worker nodes by clicking on node pools. Click on the worker nodes. And this is the compute instance, or we can say the worker node running our nginx pod. I'll open up this compute instance. I'll copy the public IP address, go back to the previous tab, maximize my Cloud Shell terminal, and use SSH OPC at the IP address of our worker node. Hit enter. As you can notice, I'm logged in into my worker node. Now I'll navigate to the location where the container logs are created, which is /var/log/container. I'll hit enter. If I do an ls-al, here are all the logs for the containers running within the Kubernetes cluster. And if you observe, we have the nginx pod log available over here. Default over here signifies that the nginx pod is running in the default namespace. And we also have entries for other containers running within the kube system namespace. I'll open up the nginx container log. And if you observe, it is pointing to the location where logs pod default _nginx /nginx 0.log. Like I had mentioned earlier, you can either use the /var log containers as the file path, or you can also go for where logs pods and use default ***/*.log. The choice is yours. Now if I open up the nginx log and hit enter, well, I have to use sudo for that. I'll use sudo at the start and hit enter. And if you notice, we have an entry within the log which says there was a GET request for test.html, which ended up with a 404 error as the test.html file was not found. In the meanwhile, I'll create other entries within our containers log. I'll go ahead and type test2.html, which again is not present on the server. Let me create an entry for a positive response. Now let's go back to the previous tab and quickly hit a refresh to see if we have the logs populated within the OCI logging service. Well, if it is taking too long for the logs to appear, we can go back to the compute instance and simply run sudo systemctl restart unified monitoring agent. We'll go ahead and hit enter. This should speed up things, and let's go back to the previous tab. I'll hit a refresh now. Well, after some 10 to 15 minutes, I'm able to see the custom logs on the screen. We can expand these custom logs to view them in JSON format. And as you can notice, this is a log entry for the GET request made to our nginx container. And if I copy the message value and paste it in a WordPad file, and we get to see that this is a GET request for the test3.html web page, which resulted in an error, and we can see the error log as well. If I expand this error log, you can see that it errored out opening up the test3.html within the nginx container. I'll copy the message value and paste it in the WordPad file. Where it says no such file or directory exists within the nginx container. Optionally, we can also click on the Actions menu and click on Explore with Log Search. This opens up the central logging search page where we can apply filter and explore and visualize the log data in different ways. We can use the stacked bar visualization or go for pie chart. I'll go back to the Explore tab. And here we can apply for custom filters. For example, if I go for nginx, I hit enter, and it will filter all the log content which has nginx in it. With this custom filter, I have zeroed down on the nginx container logs. In this lesson, we saw how to view application logs running on managed nodes and self-managed nodes. And we will continue in the next lesson, where I'll talk about viewing application logs on virtual nodes. Welcome back. Let's continue our discussion on viewing application logs on OKE worker nodes. And this time we will be particularly talking about virtual nodes. Having created a cluster with virtual nodes using Container Engine for Kubernetes, you have two options to access the logs of the applications running on the virtual nodes. You can view the standard out and standard error logs from application containers using the kubectl logs command, or you can send application logs to a persistent log server for viewing. Let's take a closer look at the first option. Well, the first option is to view the standard out and standard error logs from application containers using the kubectl logs command. But before you run the kubectl logs command, you must ensure that you have set up the cluster access using the kubeconfig configuration file. Once the setup is done, you can run the kubectl logs command by entering kubectl logs and the pod name. For example, you can run kubectl logs nginx. This is basically a pod containing single container called nginx. But if you have instances where pod contains more than one container, you must specify the container for which you want to view the logs. For example, you can run kubectl logs myapp and specify the container name. Here myapp is the pod having two containers, let's say called nginx and logging, and with this command you want to display logs, and with this command you want to access the logs of logging container within the myapp pod. Let's take a look at other approach for viewing application logs on virtual nodes. In this approach, we send application logs to a persistent log server for viewing. We start by transmitting app logs from virtual nodes to a server like OpenSearch for centralized management. Make a note, there is no daemon set support for virtual nodes, thus deploying node level logging agents is impractical. You can overcome daemon set limits by using a lightweight sidecar logging agent for each app pod on virtual nodes. Later, you can explore diverse logging agents compatible with Kubernetes pods with FluentBit as a standout option. As we conclude, you have mastered the basics of OKE application log management and dived into the OCI console to witness these steps in action. I hope you found this video helpful. See you in the next one. Thanks for watching. Hello and welcome to this lesson on Container Engine for Kubernetes metrics. I am Mahendra Mehra, your senior OCI instructor at Oracle University. In this lesson, we'll explore how these metrics play a crucial role in monitoring the health, capacity, and performance of your Kubernetes cluster. As we delve into Container Engine for Kubernetes metrics, here are key takeaways. Picture this. We are not just keeping an eye on Kubernetes clusters, we are delving deep into the individual worker nodes and node pools, ensuring a holistic view of your entire cluster ecosystem. These metrics come to you in the OCI_OKE metric namespace, making it straightforward and accessible for your monitoring needs. It's not just about monitoring, it's about having the tools to diagnose and troubleshoot issues within your clusters and node pools efficiently. Like clockwork, default service metrics are posted every 60 seconds, a steady rhythm of data points per minute offering real-time insights. You can visualize your metrics by moving to the OCI console, selecting your specific cluster and clicking on metrics. It will open up a world of default charts. It's your visual dashboard for understanding your cluster's health and performance. In essence, Container Engine for Kubernetes metrics isn't just data. It's your power tool for effective cluster management. Let's dive into the details and unleash the potential of these metrics. Let's take a look at specifics of each available metric in the OCI_OKE namespace. To start with, we have the resource ID metric. It specifies the OSID of the resource under the microscope. Next up, we have the resource display name. It's a display name that adds a human readable touch, making our metrics more readable and easier to comprehend. Now let's talk about response codes. This metric captures the code sent directly from the Kubernetes API server, offering insights into the success or status of our server interactions. Response codes often form groups, and here we have response group. This categorization is based on the first digit of the response code, for example 2XX, 3XX, 4XX, and 5XX. These response codes simplifies our understanding of server responses. Shifting focus to clusters. Cluster ID brings us the OSID of the specific cluster in question. Moving down the hierarchy, node pool ID steps in. This OSID directs us to the exact node pool associated with our metric, enabling a granular examination of performance